Problem 17. How many factors of 2020 have more than 3 factors? Whenever you see a factorization question, always prime factorize. The reason why for this is because all numbers in existence are comprised of prime numbers combined together. For example, consider 6. 6 is 2 times 3. A prime, by definition, is a number that cannot be reduced any further. Notice, there are 2 primes multiplied together to give a number that's like 6. Or like 16. That's 2 to the 4 squared, or 2 to the 4. We always multiply primes together to get all other numbers. So if we want to find all possible factors of 2020, we must prime factorize to get all possible factors. So by this logic, let's do that. 220 is 4 times 505 is 2 times 2 times 5 times 101. In other words, we're done. So 2 squared times 5 times 101 is your prime factorization. Now, once you see here 2, 2, 5, 101, by the previous definition, all numbers, right? All of 2020's factors are produced by combining these total primes together. But you don't want to just combine it out and write it out, step by step, because that's very tedious. So let's try to think of it more logically and isolate only certain numbers that we want to combine. Notice that 1 can be included as well, because 1 times 2, and 2 gets you a factor of 2020. So we have to include 1. But with this understanding, how many pairs, how many combinations of 2 numbers of these primes will produce numbers that have less than 3 factors? And the reason I'm doing this is because obviously when we combine 2, 5, and 101, we'll get a number that has more. And just from looking at these numbers alone, we can intuitively see that there will be more numbers that have more than 3 factors than numbers that have less, because we have more numbers to combine with. So if we have more numbers to combine with, by logic, we should have more numbers that have more than 3 factors. So let's do complementary counting. Complementary counting just basically is we count the number of cases that we don't want, and we subtract that from the total number of cases. That way we get the number of cases that we do want. So in other words, how many total factors are there? Well, one formula that you should remember is if I prime factorize into m to the m times b to the a times whatever and whatever, the total number of factors will be m plus 1 times a plus 1, and so on. So if we have this example right here, we already prime factorized it. So the total number of factors will be every exponent plus 1, so 3 times 2 times 2, and multiply them together, and that will give you 12. So 2020 has a total of 12 factors. But from the 12 factors, which ones have less than 3 factors? Well, from here we can just kind of brute force it, right? Because the numbers are small enough and few enough that we can just count it out. 1 times 2 is 2. The only factors of 2 are 1 and 2. That's less than 3. We can also do 5 because that's 1 and 5. We can do 101 because that's 1 and 101. We can also do 1 itself, right? Because 1's a factor. So that's just 1. So we have 4 total cases right now. But let's see what other cases do we have other than just single digits. Well, we could do 2 times 2. 2 times 2 is 4. 4 is 2 squared. So the only factor that it has is 1 and 2. So 4 would count as well with 1 and 2. But what about, for example, 2 and 5? Well, that won't work, right? Because 10 is 2, 5, 1. So 2, 5, 1 is 3 factors, so we cannot include that. So we can only have 4, 2, 5, 101, and 1. So we can stop there. We subtract 5, we get 7, bringing you to answer choice B.